Hi, I'm Eliza Marcelino and I'm going to report about hypotonic solution. Let's read its meaning so we can have some idea. A hypotonic solution is where the osmotic pressure of dissolved solutes is lower than the osmotic pressure solution inside the cell. As a result, the solution inside the cell will take in water or solvent, making the cell swell and eventually burst. Next is about hypertonic solution. Hypertonic solution is happen when the osmotic pressure of the dissolved solutes is higher than the osmotic pressure inside the cell. The solution is defined as hypertonic because the water or solvent inside the cell will force their way out to equalize the osmotic pressure, causing the cells to shrink. And based on my research, hypertonic and hypotonic solution have similarities, like they're both extracellular fluids are described in terms of osmolarity. So in both states, there are solvent molecules and solute molecules. Of course, they have difference, like in hypotonic, solution is less concentrated solution, while hypertonic is more concentrated solution. Welcome to example 3. It's me again, and let's try the difficult and last example for this lesson. Let's start to read the given problem. A mass 0.558 grams of a compound X is added to make 32.5 ml of the solution having an osmotic pressure of 675 mmHg at 2 degrees Celsius. Find the molar mass of the compound X. So here's our solution. Let's first identify the given. The mass of the solute, the volume of the solution, the osmotic pressure, and the temperature are given here. And nakuha natin ito sa mismong problem. Para mas lalang maintindihan nyo, here's the detailed info. This Mx is here, dito yung nakuha. And V solution is dito nakuha. And this is dito. And last is doon. Step 2. Let's identify what is asked in the problem. So the problem asks to find the molar mass of the compound X. Let's go to step 3. Step 3, write the working equation. And our equation is from osmotic pressure here. This is called osmotic pressure. Equals to molarity of the solution. This, letter M. Universal gas constant. This, letter R. And the absolute temperature in Kelvin, this letter T. Rearrange the equation to solve for M, or the molarity of the solution. So let's rearrange the situation para daw masolve natin ang molarity of the solution, which is letter M. So here's is the rearranged equation natin for this problem. This M is equals to osmotic pressure divided by RT. Para mas lalong maintindihan natin ang each meaning ng mga nasa equation natin, here's the detailed info of them. Here's the osmotic pressure, molarity of the solution, here, universal gas constant, the absolute temperature in Kelvin. Next step is step 4. Substitute the values. First, convert the pressure from mmHg to atm, like this. So, osmotic pressure equals to 675 mmHg and 1 atm divided by 760 mmHg equals to 0.888 atm. Alamin naman natin kung saan sila nakuha or given na ba talaga ang mga numbers na ito. So, this osmotic pressure is given na po. This, dito siya makukuha. Or, it is always ganon na po ang value na always 675 mmHg. And then once nakasulat na ang given number of this, then let's divide 1 to 760. I-compute po natin ito sa ating scientific calculator ng tuloy-tuloy. Huwag pa isa-isa para makuha natin ang ating tamang sagot. Like this. The answer is 0.888 because kinonvert natin ito into 3 decimal numbers. And don't forget to put the unit, which is the ATM. Then once na nakuha na natin yung answer sa osmotic pressure, let's substitute the values like this. Dito na pumapasok ang ating equation sa step 3, yung ni-rearrange natin. So, nakuha na natin ng osmotic pressure na 0.888 atm. Lalagay na natin ito sa numerator. Dito. And our denominator is the R and T, which is our R is equivalent to 0.08206 and 298.50 naman sa T, which is given din po ito, kaya tandaan po lagi natin ang mga given numbers nila. Then kapag na-substitute na lahat, I suggest na sunod-sunod po natin itong i-compute sa calculator para makuha natin ang tamang sagot. Next is step 5. We solve for the molarity of the solution earlier, kaya here's the final answer. Our answer is 0.0363 mole over L. After that, let's determine the amount of the solute in moles using the concentration and volume of the solution. So, N is equals to 0.0363 mole over L multiply by 0.325 L is equals to 0.0118 mole. I-multiply lang po natin sila to each other and nakuha po natin ang numbers sa mga nakuha din nating sagot earlier. Here's the detailed. Yan. Diyan po natin sila nakuha sa mga given natin. So lastly, let's determine the molar mass using the mass provided and the calculated moles. So first, let's write the working equation and then substitute the values and solve for the problem. So in this equation, given na ang osmotic pressure at ang RT. Here, divide and multiply them. Here's the answer. And next naman natin i-solve is this. Na ang mga numbers ay nakuha natin sa mga final answer natin, which is multiply by our given number the volume of the solution. This. Next is mm. Divide the mass of the solute, this, by our answer earlier. When you get the final answer, don't forget to put the units, gram per mole. And para mas maliwanagan kayo sa ating computation, here's the detailed info. Therefore, the molar mass of the compound X is 47.3 gram per mole. All done. Here's our key points or summary meanings all about our topics. And don't forget the key formulas. So, thank you for listening. I am Eliza S. Marcelino and my co-reporters is Cedric Sia and Angelica Polinar. Hi, I'm Eliza S. Marcelino and welcome to Calculating Colligative Properties for Electrolyte Solutions. We call this ideal Van Hoff factor because this is what we expect from the ionic formula, but this factor is only applicable for dilute solutions. So, solutions with concentrations higher than 0.001 m, this, have a net concentration of ions less than expected, since interaction between ions of opposite charges are stronger. Thus, the actual Van Hoff factor is less than the ideal one. Here's the equation to calculate vapor pressure lowering, boiling point elevation, freezing point depression, and osmosis pressure that are revised to take into account the effect of ionization. First is boiling point elevation in electrolyte solutions. Here is the formula, where delta TB is the boiling point elevation, KB is the boiling point elevation constant, and M is the molality of the solution of an ideal solution, and I is the Van Hoff factor. Here's the detailed info. So our next is freezing point depression in electrolyte solutions, where delta TF is the freezing point depression, KF is the freezing point depression constant, M is the molality of the solution of an ideal solution, and I is the Van Hoff factor. Again, here is the detailed names. And last is osmotic pressure in electrolyte solution, where M is the molarity of the solution, R is the universal gas, T is the absolute temperature in Kelvin, and I is the Van Hoff factor. Again, here's the detailed names para mas matandaan nyo sila. So, here's again the three equations to calculate vapor pressure lowering, boiling point elevation, freezing point depression, and osmosis pressure. Hi again! Next is example 3. Calculate the change in vapor pressure of a solution when 55.0 gram of CuCl2 is added to 700 ml of H2O at 52.0 degrees Celsius. The vapor pressure of pure H2O at 52.0 degrees Celsius is 102.1 torr, while the density of H2O at 52.0 degrees Celsius is 0.987 gram over ml. Our step 1, let's identify the given. And the given is the mass of the solute, the volume of water, and the vapor pressure of pure water and the density of water at 52 degrees Celsius are given sa problem. So don't forget them because madali lang sila mahanap. Nandito lang sila. Here. Step 2, identify what is asked in the problem. You are asked to calculate for the change in the vapor pressure. Step 3, write the working equation, which is this. Next is step 4. Substitute the values. First, let's identify the Van Hoff factor for CuCl2. I is equals to 1 as it dissociates to Cu2 plus and 2Cl. Then solve for the mole fraction of each component. And if you are done, now we're gonna use the Rolle's law to solve for the vapor pressure. Let's try it to step 5. First is multiply them. Then when you get the final answer, subtract them like this. Therefore, the change in vapor pressure of the solution is negative 3.1 torr. The vapor pressure is lowered by 3.1. All done for our all examples. I hope you learn a lot and increase your knowledge. So, here are the key formulas that will help you answer correctly. That's all. Thank you for listening to our reports, lesson 6.5.